a planet that should not exist, yet it does. And not only does it exist, it is thriving. Kepler-22b defies everything we thought we knew about planetary formation, habitability, and even life itself. It orbits a sun-like star in the perfect zone for liquid water, yet its conditions should make it an impossible world. Too big, too strange, and too different from anything in our solar system. Scientists have been baffled since its discovery, and some even believe it could be hiding something far more shocking. Is Kepler-22b an ocean planet? A super-Earth? Or could it be home to something we never expected? Get ready to uncover the secrets of this mysterious world and why it challenges the very foundation of planetary science. Kepler-22b is unlike any world we have ever known. Discovered in 2011 by NASA's Kepler Space Telescope, it holds a unique place in history as the first exoplanet confirmed to orbit within the habitable zone of a sun-like star. This means it exists in that rare and delicate region where conditions could allow for liquid water, one of the most critical ingredients for life as we understand it. The excitement surrounding this discovery was immediate. For the first time, astronomers had solid evidence that planets like Earth could exist beyond our solar system, orbiting stars just like our own. But as scientists looked deeper, Kepler-22b only became more mysterious. This planet is far larger than Earth, measuring over twice its size, which raises countless questions about what kind of world it truly is. Is it a rocky super-Earth with vast oceans, or does it have a thick, dense atmosphere that makes it more like a mini Neptune? Could life survive on such a planet, or does it challenge our understanding of what makes a world habitable? These are the questions that have kept astronomers fascinated for over a decade. In this video, we will explore the secrets of Kepler-22b, its strange characteristics, why it should not exist as a thriving world, and what it could mean for the search for extraterrestrial life. If planets like Kepler-22b are common in the universe, then our understanding of habitability may be far too limited. Could this be the key to finding life beyond Earth? Stay with us as we uncover the truth behind this mysterious exoplanet. For most of human history, the idea of planets orbiting other stars was purely theoretical. It was not until 1992 that astronomers confirmed the existence of exoplanets, and by the mid-2000s, discoveries were accelerating. However, most of these early finds were gas giants, massive worlds that were nothing like Earth. The real goal was to find something smaller, something rocky, something that could potentially support life. That is where NASA's Kepler Space Telescope came in. Launched in 2009, Kepler had one mission: to find Earth-like planets orbiting other stars. It did this by staring at a single patch of sky, monitoring over 150,000 stars for tiny dips in brightness. This method, known as the transit method, detects planets when they pass in front of their star, temporarily blocking a fraction of its light. If these dips occur at regular intervals, scientists can confirm the presence of a planet and even determine its size and orbit. It was a revolutionary technique, and it was about to change our understanding of the universe. In February 2011, scientists made a stunning announcement. Kepler had detected a planet that seemed to orbit within the habitable zone of a sun-like star. This planet, later named Kepler-22b, was about 2.4 times the size of Earth, and circled its star at a distance where temperatures could allow for liquid water. The excitement was immediate, but further analysis was needed. Then, in December 2011, NASA officially confirmed Kepler-22b's existence, publishing the findings in the Astrophysical Journal. That same month, at a highly anticipated press conference, NASA revealed over 1,000 new exoplanet candidates, solidifying Kepler's status as one of the most successful space missions ever. Scientists were fascinated. Kepler-22b was bigger than Earth, but was it rocky, or was it a mini-gas planet? Was its atmosphere thick or thin? Could it have oceans? Astronomers like William Barucki, the lead scientist of the Kepler mission, described the discovery as a major leap forward in the search for habitable worlds. The key factor was that Kepler-22b resided in what scientists call the Goldilocks zone. Not too hot, not too cold, but just right for water to exist. This concept has been central to the search for life beyond Earth, and Kepler-22b was one of the first real candidates that fit the criteria. But as more data came in, things only got more complicated. Kepler-22b should not exist as a thriving world, and the reasons why are as fascinating as the discovery itself. Kepler-22b is a world that exists in a realm of uncertainty. What we do know is that it is significantly larger than Earth, with a radius approximately 2.1 times that of our planet. Its mass, however, remains unknown. Scientists have placed an OEDE upper limit of 9.1 Earth masses, but without direct measurements, we can only speculate about its true nature. Is it a rocky super-Earth with a solid surface, or does it have a thick, gaseous atmosphere that makes it more like a mini-Neptune? These are questions that continue to challenge astronomers. One of the most intriguing possibilities is that Kepler-22b could be an ocean world. Some researchers, including exoplanet expert Natalie Batalha, have speculated that it might be entirely covered by a vast global ocean, a scenario that raises fascinating questions about the potential for alien life. If it has a dense atmosphere rich in water vapor, the surface could be a warm, endless sea, possibly supporting exotic marine life forms. However, an Earth-like composition, rocky with continents and oceans, is considered unlikely. It is also possible that Kepler-22b has a thick atmosphere dominated by hydrogen and helium, making it less hospitable for life as we know it. If that is the case, any surface beneath the clouds could be a hostile, high-pressure environment, more like Neptune's interior than Earth's surface. Kepler-22b orbits its star in about 290 days, making its year only slightly shorter than ours. Its distance from its Sun-like star is roughly 85% of Earth's distance from the Sun, placing it well within the habitable zone. But the big question is temperature. Without an atmosphere, its equilibrium temperature is estimated to be around 6 degrees Celsius, 43 degrees TF, which is close to Earth's global average. However, the presence of an atmosphere could dramatically change things. If it has an Earth-like greenhouse effect, temperatures might reach a comfortable 20 centigrades, but if it has a runaway greenhouse effect similar to Venus, surface temperatures could soar to an uninhabitable 460 860 detour. The truth is, modeling exoplanet climates is incredibly complex. We cannot simply assume that because Kepler-22b is in the habitable zone, it is actually habitable. Factors like cloud cover, atmospheric composition, and internal heating all play a role in shaping a planet's climate. Kepler-22b could be a paradise, a scorching hellscape, or something entirely beyond our expectations. And that is what makes it so fascinating. It challenges us to rethink what we know about habitability and the diversity of worlds beyond our solar system. Kepler-22b orbits a star that is remarkably similar to our Sun, Kepler-22, a G-type main-sequence star located about 600 light-years away. At first glance, Kepler-22 could be mistaken for our own Sun, but there are subtle differences that make it unique. It is slightly smaller, with a mass about 3% less than the Sun and a volume that is 2% smaller. This means it emits a bit less energy, which directly impacts the conditions on Kepler-22b. With a surface temperature of approximately 5,518 K, 5,245 degrees, or 9,473 degrees, Kepler-22 is just a few hundred degrees cooler than the Sun. This small difference affects the type and intensity of light reaching Kepler-22b, potentially influencing its climate and atmospheric composition. Interestingly, Kepler-22 is also younger than our Sun, estimated to be around 4 billion years old compared to the Sun's 4.6 billion years. While this might not seem like a huge gap, it could mean that Kepler-22b is still undergoing evolutionary changes, either in its atmosphere or surface conditions. Despite its similarities to the Sun, Kepler-22 is completely invisible to the naked eye. With an apparent magnitude of 11.5, it is far too dim to be seen from Earth without a powerful telescope. This makes direct observations of its system challenging, leaving astronomers to rely on indirect methods, like the transit method, to study Kepler-22b. Even though Kepler-22b exists in the habitable zone, the star's subtle differences compared to the Sun introduce more questions. How does the slightly lower energy output affect potential habitability? Could it lead to a thicker atmosphere or different weather patterns? These are the mysteries that make Kepler-22b such a compelling target for future studies. Kepler-22b sits in what scientists call the habitable zone, the region around a star where conditions could allow liquid water to exist. This is often referred to as the Goldilocks zone, because it is not too hot and not too cold, making it a prime location for potential life. But just because a planet is in this zone does not automatically mean it is habitable. Many other factors come into play, including the planet's atmosphere, surface composition, and internal structure. Without these key ingredients working in harmony, a world can go from a potential paradise to an inhospitable wasteland. Kepler-22b has been included in an optimistic sample of potentially habitable exoplanets by the Habitable Exoplanets Catalog, meaning it meets some of the basic criteria for supporting life. However, a closer look reveals complexities that make its habitability uncertain. One major factor is the energy output of its host star, Kepler-22. While it is similar to the Sun, slight variations in its radiation could influence Kepler-22b's climate. If the planet has a thick, heat-trapping atmosphere, it might experience a strong greenhouse effect, making conditions too hot for life. On the other hand, if it lacks a substantial atmosphere, it could be too cold for liquid water to exist on the surface. Another intriguing possibility is the existence of exomoons, moons orbiting Kepler-22b that could themselves be habitable. Scientists have searched for evidence of exomoons using transit timing variations, looking for subtle shifts in Kepler-22b's orbit that might indicate the presence of a large satellite. The hunt for exomoons with Kepler HEK project conducted an extensive analysis, but found no signs of a moon larger than 0.54 Earth masses. This means Kepler-22b is unlikely to have a massive Earth-sized moon, but smaller moons might still be present and could offer additional environments where life might emerge. Moons can play a significant role in planetary habitability. In our own solar system, icy moons like Europa and Enceladus harbor subsurface oceans that might support life. If Kepler-22b has smaller moons with stable orbits and protective atmospheres, they could be prime locations for habitability. Even if Kepler-22b itself is not suitable for life, its system could still hold the potential for living organisms in ways we have yet to fully understand. The search for habitable worlds is not just about planets. It is about entire systems that might support life in unexpected places. Kepler-22b remains one of the most intriguing exoplanets ever discovered, but much about it is still a mystery. To truly understand what kind of world it is, scientists need better tools, more advanced telescopes capable of directly studying its atmosphere, composition, and climate. Fortunately, new technology is already changing the way we explore distant planets, and some of the most powerful instruments ever built are set to take a closer look at Kepler-22b in the coming years. One of the most promising tools in this search is the James Webb Space Telescope, JWST. Launched in 2021, JWST is designed to study exoplanets in unprecedented detail. Using its infrared capabilities, it can analyze the atmospheres of distant worlds by detecting how starlight interacts with the gases surrounding a planet. If Kepler-22b has an atmosphere, JWST could determine its composition, potentially identifying key elements like water vapor, carbon dioxide, or methane, molecules that could hint at habitability or even biological activity. If Kepler-22b has a thick, Neptune-like atmosphere, JWST might detect heavy gases like hydrogen and helium, which would suggest it is more of a gas planet than a rocky world. Beyond space telescopes, ground-based observatories are also advancing rapidly. One of the most exciting upcoming projects is the European Extremely Large Telescope, EEELT, which is currently under construction in Chile. With a massive 39-meter mirror, EELT will be the largest optical telescope ever built, capable of directly imaging exoplanets and analyzing their light spectra. Once operational, it could help confirm the atmospheric properties of Kepler-22b and other distant worlds, further refining our understanding of which exoplanets might be truly Earth-like. Scientists have several key questions they hope to answer. Does Kepler-22b have a solid surface, or is it entirely covered by a deep ocean? What gases are present in its atmosphere, and could they support life? How does its climate compare to Earth's? Every new observation brings us one step closer to understanding whether Kepler-22b is a thriving world or a planet that only seems habitable from a distance. The answers to these questions could change the way we think about life in the universe and bring us closer to finding a true Earth twin. Kepler-22b is just one piece of a much larger puzzle. The search for life beyond Earth has expanded dramatically in recent years, with thousands of exoplanets discovered and many more waiting to be found. While Kepler-22b was one of the first habitable zone planets identified, it is far from the only candidate. Worlds like Proxima Centauri b, TRAPPIST-1e, and TOI 700d have also captured scientists' attention, each offering unique conditions that could support life. The challenge is determining which of these planets are truly habitable and which only appear promising from a distance. This is where ongoing and future missions come into play. NASA's Transiting Exoplanet Survey Satellite, TESS, continues to scan the sky, searching for exoplanets around nearby stars, while the James Webb Space Telescope is beginning to analyze the atmospheres of these distant worlds. But exoplanets are not the only targets in the search for life. Within our own solar system, places like Europa and Titan present compelling cases for extraterrestrial habitability. NASA's Europa Clipper mission, set to launch in the 2030s, will explore Jupiter's icy moon, Europa, where a vast subsurface ocean might harbor microbial life. Meanwhile, the Dragonfly mission will send a drone to Saturn's moon Titan, a world with thick clouds, methane lakes, and the chemical ingredients for life. Together, these missions are pushing the boundaries of what we know about life in the universe. Kepler-22b serves as a reminder that habitable zone planets exist, but it also highlights the complexities of determining whether they can actually support life. As technology advances, the next generation of telescopes and space probes will bring us closer to answering one of humanity's greatest questions. Are we alone? Whether life is found on a distant exoplanet, an icy moon, or even in an unexpected place, The search itself is transforming our understanding of the cosmos. Kepler-22b is a planet that challenges our understanding of what makes a world habitable. From its groundbreaking discovery as the first confirmed exoplanet in a Sun-like star's habitable zone to its puzzling characteristics, it remains one of the most intriguing planets ever found. Its size, composition, and atmosphere are still mysteries, leaving scientists to wonder if it is a warm ocean world, a mini Neptune, or something entirely unexpected. While it sits in the habitable zone, true habitability depends on many factors, from its atmospheric conditions to its climate, and without direct observations, the answers remain out of reach. What makes Kepler-22b so important is not just what we know about it, but what it represents, the idea that planets like Earth could be common in the universe. Every new discovery brings us closer to answering one of humanity's biggest questions. Are we alone? Whether Kepler-22b turns out to be a thriving world or an uninhabitable one, it serves as a stepping stone in the search for life beyond Earth. The excitement surrounding future observations, with tools like the James Webb Space Telescope and the Extremely Large Telescope, means we may soon uncover even more details about this mysterious exoplanet and others like it. If you find the search for alien worlds as fascinating as we do, stay tuned for updates on Kepler-22b and other exoplanet discoveries. There is so much left to explore, and each new mission brings us one step closer to unlocking the secrets of the universe. Do not forget to subscribe and follow for more deep dives into the mysteries of space. What do you think? Could Kepler-22b be home to life? Let us know in the comments below.